we have Gerred with a beard that I think can compete with one of our speakers yesterday. I don't know if you saw yesterday our speaker. Oh my gosh, I'm spacing his name. Chris Brousseau.
I'll take the competition with it. That sounds good.
Yeah, not only did he have a beard that could almost compete with yours, he also tied in a metaphor for the beard in his talk. So I don't know. We'll have to send that to you later. But
Now I'm so unprepared. Yeah.
I know. You're going to be great. Okay, so I don't want to eat into your time. Without further ado, let me pull up your slides. Oops. All right. Thanks so much.
No, thank you. Hey everyone. Thanks for coming to this. I'm talking a little bit about what local LLMs and LLMs in production means for missions and defense and public spaces. So, uh, without further ado, just a quick intro. I'm a unicorn engineer at a company called Defense Unicorns, where we work on very critical missions for defense and in other arenas. So I'm an open source developer. I've done a little bit of founding startups, and currently I work on building generative AI for critical defense missions. So let's talk about a little bit of what that means. And we're going to start off with the fact that regulated environments are incredibly challenging to work in. So the past few months, weeks has been a shell shock for these environments, where just yesterday it was revealed that a massive global cyber attack happened. Data was exfiltrated from multiple states, multiple financial institutions, multiple industrial components, as well as the US government. And this is a story that has played out multiple times in the past couple of years, as the amount of data, the amount of gravity towards these systems, and the importance of this system grows. So that's led to a very interesting question of, what does generative AI, what do large language models mean for federal defense sorts of missions? So we're talking about, from one side, we're talking about like a lot of regulation coming from some of the largest creators of AI and LLMs out there, but also declarations of from a government side of, how do we figure this out? How do we acquire this? How do we manage the risk of it? And going down to having industry experts and other people come in and talk about these in spaces, because I think there's a recognition that solving this is critical, and we'll talk a little bit about why that is. But we can't just ignore this problem from these environments. So let's start a little bit. What is a regulated environment, right? Like, we should define this term, because that could mean that could be easily be a weasel word. It could mean nothing. It can mean a lot. The way we look at them at Defense Unicorns is, they're first and foremost very mission purposed environments. They're suited out to define and achieve a set of goals that is widely applicable or narrowly applicable to some other domain. Right. And often these are very restricted, regulated, otherwise isolated. We'll talk a little bit more about that. But uh, in some way, these environments are restricted to who can access them, why, how, who can develop on them. They're often very egress and ingress controlled, and it's easy to say air gap, but often these can be completely air gapped. These can be completely on the edge in various theaters, or they just may have a lot of controls and restrictions around them. And so that often even has a fine meaning in and of itself. I think one of the most important things, though, that these are often very high value targets, as we see with the cybersecurity issues, up to a nation state level from an attacker and a defense perspective. So in that, we're often talking about areas like finance. We're talking about healthcare data, and access to healthcare data and leaks of that is very critical, as is financial data. We're talking about civilian government data, and we're also talking about defense data that goes up into very sensitive information that creates very serious security issues for nation states if that were to leak. So what's the problem with just going and using these APIs, these tools in these environments? Well, first off, there's often a perceived resistance to innovation, and whether it's not true or not is not part of this talk. But if you were to ask, often I find in conversations, these spaces are so heavily burdened by that regulation, they just don't want to innovate. They're living 20 years behind. I find that often not true, but sometimes that's in the eye of the beholder. What is absolutely true is there's very high requirements for deployment and operation in these environments. And we'll talk a little bit about authorization to operate. We'll talk about some of the data needs. We'll talk about Iron Bank, but there are steps. You can't just deploy. You have to actually go through steps in order for this to go run, even at a very granular level. And that can often differ who you speak to, the processes that you need to go through with that. Alongside that, you need to go through a lot of artifact control requirements. And most recently, people have been dealing with that with containers. But if you look at large language models and other generative AI model weights as an artifact, those control requirements will continue to become more and more important as well. Now, a lot of this may look like, okay, well, we just won't innovate there. And I would posit not only can innovation not stop in this arena, that it is a critical issue if we do start to challenge the fact that innovation does need to happen in these spaces. And I really want to focus in on this thought that innovation and the availability of these models does not change anything, and pushing for that innovation, especially in these regulated environments, in these defense missions, is very critical as part of a partnership with open source spaces and spaces relevant to the talk that I'm talking about here today. So I'm going to refer over to a talk that Mark Andreessen put out just recently about why AI will save the world, and it's a very long treatise around a lot of the fear, uncertainty, and doubt around the regulation of smaller entities and smaller models and innovation in the large language model and generative AI space. And one that stands out and is the the real effects for stifling innovation in an arena where others will continue to move forward with that innovation and in fact have their own views on it. And I won't read this quote out. It's worth reading this blog post to go and form your own opinions. But the the reality is that AI is a very competitive environment that often has and right now we believe that AI is at a very critical inflection point. If you look at all the innovations daily, it's almost a full-time job just to keep up with what's going on in open source in the industry, much less the needs that are being created in real time from all that demand and all that supply. So one thing I would posit in that article is that power projection in AI is real. And so what does power projection mean? Well, power and how does that apply to generative AI? Well, power projection in that generative AI space is really about changing the relative cost of conflicts fought across domains. So what the real benefit of generative AI in these missions is an opportunity to make conflict domains far less expensive for these environments to work in and incur a far higher resource cost to adversary actors initiating and engaging in conflict. And if you look at that across domains, we're not just talking about kinetic domains, but cyber attacks. We're talking about every domain in which nation states and others interact with each other. And not taking advantage of that is creates an imbalance that we're working against. So how do we start to enable this sort of innovation? What's our next steps to get there, right? And we're looking at it as we need to actually be in a community space. So local generative AI solutions are critical for this. And one thing I really loved from the modular talk at the last LLMs in production part one was seeing that small local LLMs can really excel at specific tasks. And I'm speaking to the Stanford, I believe it was a 3 billion model that really outperformed at the time others on healthcare Q&A questions, right? We're now in an environment where we're looking at new LLMs or generative models a day. I think right now I'm working with Wizard 40B for code that's really trying to like build out on and 2 days before that I was looking at StarCoder Pro. So the rate of change in LLMs is massive, and the tools need to be as accessible as the rate of release of these models themselves. Not only that, there was a problem early on where, okay, where do I get all the chat and instruction tuned data for these models, right? And so we're starting to see these big corpuses of open source chat instruction tuned uh, fine data. And recently, I think in the past couple days, just saw an entire fine tuning that was based off of effectively what OpenAI's new function tuned modeling is doing. So this is continuing to grow. It's not stopping, right? From that perspective, then, it's critical to be part of the community. Let's not build two classes of tools that nobody else uses. Let's enhance that while also gaining the benefits in both directions. So, okay, how do we get to that innovation? Well, we want to build open source tools designed for mission oriented environments, highly regulated environments. That needs to be multimodal. And the important part about there is not about just LLMs, but speech to text, image to image, text to image. All of these provide value in different ways. And the availability of those is critically important to be able to create a complete solution. And we'll show some demos. I'll show some demos in a few demonstrating that. And then having MLOps tooling around this. So I'm talking about the tooling to go fine tune, to go observe, to go deploy and deploy in a variety of environments benefits everyone working in the open source as well as these environments that have these restrictions. But I believe they have to have parity to existing open source tooling as well as proprietary APIs. So being able to go drop in Llama Index, LangChain, guardrails, Microsoft's guidance tool, I believe that is critically important to be able to drive adoption there with small LLMs and being able to drop that right in, ready to go, be it whoever's API is backing that. So today I am, I guess, introducing formally for the first talk, but we've been open source for a little while, something that Defense Unicorns has been working on called LeapfrogAI. And what LeapfrogAI is an open source, open contribution suite of APIs and tools for everything from deploying, running, performing day two operations on, everything you need in one package to do generative AI in these very adverse, highly regulated environments. So out of the gates, we designed Leapfrog to be ready for egress limited and ingress limited environments. So anything air gapped to highly controlled. Regulated, so these areas need complete ownership of their data. They can't put that data in other places. Sensitive in the sense that access to the APIs and the data itself is very limited, both from and maybe different for who is developing, who is creating the tools, and who is using the tools. And secure. So we were coming out of the gates ready to go with very hardened containers. We're looking towards authorization to operate so that that various arenas can go pick them up and go use them, and that is kind of built into the core of what Leapfrog is doing. So where are we at today? We are sitting with an OpenAI compatible API. I'll show that in a few minutes. We have LLM support, so actually building models out is really just creating new gRPC backends, which we've built a harness and tool to be able to do. And I'll show a little bit about that. And we have a community space to come do that. So we support both gRPC and HTTP for backends for these models. And speaking of HTTP models, we have speech to text support. So that's where we're using Whisper Large V2 in that example. We have support for embeddings and embeddings models, so a text-to-vec support. And it's designed really out of the gates to run a distributed environment. So every model that we have up there right now supports GPU and CPU, and actually MPS, the metal shaders for that matter. And so when I say distributed, our default deployment instructions go over Kubernetes. They're assuming that you have a cluster of machines instead of often tools will expect you to have a big monolith that you're running one thing at a time, you're loading in and out. In this, you can actually go start to scale Leapfrog from day one. And right now we're shipping with Weave8 from a vector database perspective because we wanted people to really get started with being able to add in vector embeddings into these prompts very quickly. So I'm going to take a quick look as I switch over. I'm going to take a quick look at questions while I switch over to my demo environment. Okay, I don't see any for the moment. So I'm going to switch my screen share and go over to, let's see here. First off, let's do a terminal-based demo. And I'm just going to throw up, let me make it a little bit bigger for the purposes of the slideshow. And I'm going to go import OpenAI. And we wanted this experience right out of the gates. We wanted to be able to do that with Hugging Face. And as part of that, caching models in a model zoo in browser, we'll talk about that. But if we just set the OpenAI base URL or API base, and we put in a key, right out of the gates, we can start to look and list models that are out there available if I were to choose the right API base. This is the Cursor Live demos. So we'll go model list, and now we have our list of models. So we have stable M3B tuned here. We have text embedding 802. This is actually stable, mini LM. It's in the repo. I can demonstrate that. All mini LM L6V2, and we have Whisper. So if I were to come in here, I can go create a completion, and this is federating out, so it's hitting the front end API server, and from there, this completion goes over gRPC, is able to stream back to another backend, and so ready out of the box is very critical for us that these community tools just work. And so we have a response. We've got the tokens. So that's one way to use it. And out of the gates as well, we have an embeddings response endpoint. So for people working with our vector database, they can go get vectors just ready to go. So I'm going to switch over to one more set of demos here, and then get back to the slides. Let's see here. So we actually hosted a internal hackathon once this was starting to get released, and we were wanting to use it internally. And so other unicorns, some of my colleagues actually went out and built applications over the past couple days. This was Thursday, Friday, demonstrating all the things you could do with this. And so one of them built, Doug is the Defense Unicorns mascot. So we actually built out a Doug Translate tool. So if we drop in a translation, and this is the speech from Yuri Gagarin launching the Soyuz, we can do that translation. And it's even multimodal to where you can hit summarize with it. The stable LM3B is interesting in its translations, but that's why we wanted to be able to have a zoo and a propagation of model availability. So it takes about 100 or 10 seconds per minute of audio. So it should return back here in a few seconds. And so we have that translation. We'll skip the summarize for now, but that goes back and hits stable LM3B for that. And then one more thing we did was with the code model, be able to go in and ask, plot air quality data on June 6, 2022. And so this was actually able to generate out that plot, get that data for us, and be able to form that. And this is really representative of a lot of the real things going on in these environments and the things that they work on. So I'm going to go back to my slides now. Bear with me. Here we go. So to look at the roadmap real quick, and Lily, on your end, do those show back up okay? I'm going to go with no, yes for that. What we're looking at from a roadmap. Oops. There we go. My page was unresponsive. So back from a roadmap perspective, let me make sure that didn't drop me. I seem to have frozen. Okay, we're back. So from a roadmap perspective, we're working on GGML and 4-bit quantized model support. We want to be able to support more models in more places. We want to be able to do a model zoo in a registry, and then enable APIs for fine-tuning and performing model availability for these missions. We get a lot of questions and requests to be able to take a model, fine-tune it, and continue to use it. proper APIs for document management and ingest, and really just adding more models in. So with that, I wanted to thank everyone for coming to this talk. Really appreciate the time and everyone spent to come listen to this. And I guess I'll turn it over to questions, Q&A, but also talk about like how to come contribute. So we're open source, open contribution. This we're working with various open source foundations to find a home for this. The repo is available there. We have a Discord community. And then come check us out at Defense Unicorns. And one thing is all of this would not be possible without a tool called Zarf that allows us to really quickly, another Defense Unicorns project, that allows us to very quickly deploy and get tools like this into production in air-gapped environments.
Woo! I feel like sometimes with the virtual conferences, you don't get the kind of like applause that you do in an in-person. So I want to try and replicate it. Thank you so much.
Thank you. That's a thunderous applause for one. So thank you.
Yeah, all yours, all yours. You don't have to share it with anybody. Thank you so much. Let's give it a moment. There's a bit of a delay, so I want to give people a chance to drop questions in the chat if they have them. And also highlight the WeVH shout out. The MLOps community is actually partnering with WeVH to do a couple hackathons. We have one in Berlin happening tomorrow, so it's cool to see that you've used WeVH and have found it to be useful.
Yeah, we interact with them. We've had a lot of success with WeVH. I can't recommend them enough. If I'm doing local work, I'll use Chroma, but for us, for WeVH, they also just announced multi-tenant support, which is really important for us in these environments. So being able to fully bifurcate all of the collections at a system level, critical for that type of work.
Awesome. That's great to hear. All right, people, put your questions in the chat. And I think what we're going to do on this stage, once we let Gerred go, is we're going to have a dance break. Gerred, you should tune into that after this. Demetrios has a dance break for everybody to move a little bit. So maybe I'll send you to the chat. Maybe you can share some links there and answer any questions for folks. And yeah, this was awesome. Thank you so much.
Yeah, no problem. And actually, to follow up on that, I'm in the MLOps.community Slack. I'm in this chat, and we have our Discord as well for longer term questions. And then again, open community, so people can come open issues. So available in lots of areas for follow-ups.
Awesome. I love to hear that. That's great. Cool. All right. Well, have a wonderful rest of the day. We appreciate it so much.
Thank you.